Underfitting, overfitting. We already explained this, right? So again, very fast we can go. Underfitting, where your model cannot capture the patterns from your data, cannot capture the patterns of your data. And we call it high bias. Soon maybe I'll explain to you what does it mean. So like the case here, this is the case for regression. This figure is for regression because classification will look different. So this figure is for regression. So the first case is underfitting. Why? Because the model is not able to capture the pattern. Actually, if you look to the data has a pattern like this. But eventually the model is not able to capture this pattern. So underfit. Overfit is actually where your model is very powerful. Like the snake game. You know the snake game? Where you try to cross you eat, there's pills on the whiteboard or the dashboard, the game board, and then you keep eating them. Same. So if your model looks like the snake game, where it can try to cross as many data points as possible, then this is overfitting case. So your model actually what is doing, trying to memorize the data point. How memorize? By crossing them. If your model cross data points, like the snake game, that means your model is memorizing the data points. The best one is this one, where you try just to capture the pattern. Not trying to capture even the variation, the small variation inside the data set. You capture only the pattern. Because this variation can be due to noises, right? Can be due to noises. Actually, if you don't have maybe new noises at all and crystal clear, you have case, then yeah, of course, your model is gonna cross data points, should be fine. But this is not the situation in real life. Real life, always you have noises. So you need your model just to capture the pattern while avoiding focusing on the noises. Because these noises can be, going up and down is noises. So here the model is trying also to capture the pattern plus the noises. This is why I end up overfitting. Now we come to these two words. What do we mean by high bias for the case of underfitting? Bias simply means how far your predicted value from the actual value. How far your predicted value from the actual value. Okay? Clear what we mean by bias? So what does it mean here, high bias? The case of underfitting, do you think the bias is high or small? As I said, the difference between the actual Y and predicted Y. Underfitting, that means it's going to be far. So it's going to be high bias. During training set, during test set, doesn't matter. Always your model is not going to be able to capture anything. So you ask him about predicting the income or the performance of a person, you give him characteristic of A student, he give you C. Very far. Okay, bias. During training or during testing, always is high. It doesn't matter. Okay. How about high variance? High variance is different. High variance, meaning here we're not talking about bias. Here in overfitting, we're not talking about bias. Okay. We're talking about what? Variance. What do we mean by variance? Variance meaning comparing the results or the performance of the model during training time and testing time. Clear? So variance means here we're looking to compare the performance of the model during training time, during testing time. If the model overfitting, why variance would be a good way to sense that? Because during training time, the performance of the model is going to be quite good, right? But during testing time, it's going to be quite bad. So there's a big high variance in the performance. During training time, wow, perfect. During testing time, very bad. So the variance is quite huge. Okay. While in underfitting, can we use variance? No, because variance is high all the time. No, sorry, variance is going to be low because anyway, the quality of the performance is bad in both cases. Bad during training time, bad during testing time. Right? Like imagine here, there's a student come to the class, and then I check his assessment all the time is bad. Then when we go to the final exam, it's also bad. Is there any surprises? No. So the variance is going to be low. There's no big differences between his assessment. So this person definitely underfit the course. Probably I check his record, he's not attending the class. His marks always low. If I ask him, maybe he doesn't answer, he doesn't know the answer, and so on and so forth. How about overfitting case? Different. Maybe the student come here, I check his assessment, in quiz, midterm, always good, high mark, A. Suddenly he come to the final exam, he gets C. Oh, right? So that means there must be a problem, correct? When the student, should be A student, suddenly I find C. Then maybe I go and investigate the type of question I given during assessment time. I find out that all the questions were coming, let's say, from your training sample. Exactly same problem. Whatever we're discussing in the slide with the same figures, everything, copy paste. While in final exam, maybe I sit alone and try to manipulate the figures. Same problem, but manipulate the figures. So that will help me to explain. I will understand that the student was not understanding the course, but was memorizing. So during training time, he was fine because I give him a set of questions coming exactly copy-paste from the training materials. But during testing time, he failed because he couldn't understand the problem. Though the problem is same, already discussed during training time, but I changed the figure. Like the student, I'm sure happened where you attend exam, and maybe before the exam, there's one, maybe let's say topic you don't understand. So what do? Just you go memorize. I'm wishing the same example comes during the final exam, right? If comes first, is your happy day. Blah, 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 blindly, just you answer, you go out. If the lecture has changed the figures inside, you are lost, all right? So that means overfitting, trying to memorize, but not trying to comprehend, understanding the patterns inside the course. So reasons behind underfitting: the model is too simple to capture the underlying pattern. Like I go bring student from primary school student and put him on beside degree students. So his model, his brain model of complexity in his brain is simple, too simple to comprehend complex course materials. Okay, so similar thing. So too simple to capture the underlying patterns. Okay, or maybe the model is not the problem. The model maybe has the capacity to be mature, or maybe can to understand complex problem. But I put too many constraints. I put too many constraints on the model. Okay, I put too many constraints. Later we understand what we mean by constraint. Like for example, if we're talking about decision tree, right? Remember decision tree has branches, right? Then I go and say decision tree, well, you cannot have more than level 1. So I put restriction on the model. So the model cannot be trained freely. I put restriction on the model. Okay, so this can cause underfitting. Or maybe I reduce the number of iterations. Maybe the model need to do revision many times in order to capture the pattern, but then I say only you can train one time only on this materials. You don't have second chance to look at the materials. Anyway, so we put some restriction. Then as you are data miner or data scientist, right? So how do you need to diagnose the problem? You put your, like those professional medical doctor, you put what's called this one on their ear and try to inspect what is the problem of your model. So what do? You can look for the training error and generalization error. If error is high during training time, generalization means like using the test set, right? So you find error is high. During training time is high, and also during test time is also high. That means underfitting. Okay, how about overfitting? Since we're talking about the sign, training error is going to be low, generalization error is going to be high. This is overfitting. Okay, how about the remedies? How you can solve the problem of underfitting? Select more powerful model with more parameters. So instead of selecting, let's say, primary school student to solve this problem, I go maybe take high school student. right? I take a model that has higher complexity, more mature, or more number of parameters, we call more parameters, okay? Feed better features. Maybe the features you are providing is very bad. Irrelevant features, remember garbage in, garbage out. Or you can also reduce the constraint, because just now we said you may have high constraint. So go and reduce this constraint. So instead of telling decision tree, you are allowed only to grow to level of 1, maybe you make it level 2 or level 3. You give more freedom to the algorithm to get trained. Okay? Reasons for overfitting. The model is very complex. I go bring a degree student and give him a problem for primary school student, for example. So the complexity of the model is too high for the problem you have, okay? Or you have limited training data. Because remember, insufficient amount of data is one of the main challenges of building model in machine learning or data mining, right? So you have limited training data, or you have noisy data. The data is very noisy and you cannot capture any pattern. It's very difficult. And you keep training the model, keep pushing the model to train. The only way the model to show you good performance, but just by memorizing. There's no other way, because it has many noises. So there's no clear difference how you, like for example, I give you a data set of cars. Let's say you need to predict the car price, but the data is too noisy. You cannot find any pattern. You cannot tell as, for example, you may say as the car newer is more expensive, but you go to the data set, you find many cases where the car is very new but very cheap, and many cases where the car is very new and very expensive. So there's no pattern inside the data, and you need to show good performance. The only way is to memorize. So you say this car by itself, only this type of car is expensive. This car is cheap. Why? We don't know. Just you memorize. Yeah, it can be. Depends. I mean, sometimes you can say both. If you're not able to, again, how to decide whether underfitting or overfitting, you need to check the performance. If during training time, the error is high, testing time high, underfit. If training time error is low, that means the algorithm is able to do some work. But during test time is very high, that means overfit. Okay, so always the way to diagnose, you need to look to the performance during training time and during testing time. Like the example for student, I always like to bring student case because all of you live this experience. So for me, I should check the assessment time during the semester and your final exam. If I find assessment time, your error is high, your mark is very low, and during final assessment is also low, that means underfit. If I find assessment time, your performance is high, you are A student, and then suddenly I find your final exam performance is very low, that means overfit. Okay? Or low regularization means here we're talking about the constraint. Constraints, we said before. Constraint can be, if too much constraint, too much restriction can end up with underfitting. If you don't put constraint into the model, also can end up with overfitting. So you need to find a balance. You need to find a balance of constraint. Okay, like the example of decision tree. If decision tree you allow to grow for level 100, where maybe the suitable level enough to be 10, then definitely overfitting, because you are giving the freedom for the algorithm to memorize. If you put too low, as we said, maybe the optimal is 10. You put too high, that means you have low regularization. This is example of low regularization. You give freedom to the algorithm. There's no constriction. Okay, there's no restriction. While if you put regularization is too high, let's say you say level of degree 3 is only 2, then here the case your model, same model, decision tree is going to be underfitting, while here overfitting. So the point is you need to find the correct balance of restriction, which can help you to capture the pattern while avoiding the noise. Okay? Clear? Okay. Signs of overfitting, already explained. Now the remedies. What do you do in case you have overfitting, like in your assignment? You found logistic regression is very good. You took it, but you check it has overfitting. What do? You go throw it away? No, you don't throw away. You need to provide the remedies, right? So what do? You can simplify your model. Let's say you're going with decision tree or regularize your model, same thing. Maybe you are going with decision tree, or let's say here we're talking about regression, same. Decision tree, okay, where there's level of, what's called? Just now I was saying the level of tree, the depth, they call it the depth of the tree. The depth of tree is 100. That means the decision tree, while the optimal depth, as I said earlier, should be 10, right? That means your algorithm is too powerful with depth 100, can do a lot of things, right? So you need to reduce, simplify, or regularize. Regularize here means put restriction. So I go and say, oh, instead of depth 100, only the maximum depth is 10. I put restriction. Or maybe I change the algorithm. Maybe I'm using a neural network. A neural network is very powerful, and I have very limited data. Then I don't use neural network. Maybe I go with simpler algorithms. Get more training data. Can also, due to, as just now we said, limited amount of data can end up with training overfitting, right? So you need to increase your amount of data. Go collect more data. Clean up the training data from noise, or the data has a lot of noises. As I said earlier, you have many cases for car, very old yet very expensive, many cases for car, new and very cheap, right? So you need to clean your data, find why these noises exist inside the data. Is it error, due to error, or maybe due to something else? You need to find out and reduce. Okay? Always you need to, as we said earlier, always you need the performance. You need to check the model performance in order to determine, right, whether the model is overfitting or underfitting. But hey, remember we said earlier, test set we never touch, correct? Then how can I get the generalization error, right? Just now I told you earlier here, and you see nobody says anything. In order to determine, you have, for example, here underfitting, you need a generalization error, which is an example using the test set. But can you use test set during modeling time? Cannot. Then what do? Validation. So you use validation set, right? So this is why it says here, you need to eventually to estimate the model generalization performance by using the validation set. Of course, not only validation, we need to apply it with a technique called cross-validation. We're going to talk about it soon. But the point is, I need to use validation set. Test set never touch. As I said, until you are happy. That means your model showing good performance, no overfitting, no underfitting. Everything look very good. Only then you go with test set. Clear? If you have overfitting, don't use the test set yet. That means you need to solve the problem of overfitting. You have underfitting, you need to solve the problem of underfitting. Only then you proceed to the test set.